this is Miss Rika, and I'm coming at you with another video. In this video, we are going to be working on assignment 4 for the 7th graders. The title of the worksheet is Additional Practice, and the additional practice is specifically on scale factor and similar figures. I think it's going to be super fun, and you picked the right video to watch. Okay, so before we get started, I do want to clear a couple things up about scale factor. So this is just to clear a couple things up. So when a figure is similar, that means that it doesn't necessarily mean that the side lengths are the same, but it does mean that the side lengths are proportional. When figures are similar, it means side lengths are proportional. And by this, I can show you right here. So if the width of this rectangle is 2 and the length is 6, and the width of this rectangle is 4 and the length is 12, and I'm told that these rectangles are similar. If I'm told that rectangle A and rectangle B are similar, then I know that their side lengths are proportional. So the length, so to get from this length to get from this width 2 to this width 4, what do I multiply by? 2. To get from this length 6 to this length 12, what do I multiply by? 2. So my scale factor is 2. The scale factor is what is being multiplied by one side to get to the new side. So let's do another one. Let's do triangles. So these are similar triangles. So based on that, I know that if these are similar triangles, I know that the side lengths are proportional. I know the side lengths are proportional. So if this side length is 3, this side length is 12, this side length is 4, this side length is 16, and this side length is 1, I could solve for x right here. And I could figure out what the scale factor is by setting up a proportion. Well, this side length corresponds with which side length? This side length. So I can set up a proportion. 3 over 12, this side length corresponding with this side length, 3 over 12 equals 1. This side, which corresponds with this side of the triangle, 1 over x. And to go from 1 to 3. So to get from 3 down to 1, what am I dividing by? I'm dividing by 3. To get from 12, so if I'm dividing by 3, to get from 3 to 1, I divide by 3. And if I do that in the numerator, I need to divide by 3 in the denominators. So 12 divided by 3 is 4. So that means that x is 4. So 3 times what equals 12? 4. 1 times what equals 4? 4. 4 times what equals 16? And that matches all of my side lengths, so my scale factor is 4. We're going to do a couple more before we get to the, what am I trying to say? Until we get to the problems in the homework. So let's see. So if I'm given the scale factor is 8, and I'm given this triangle, and I'm given that this triangle and this triangle are similar, that means that if they're similar, that means their side lengths are proportional. And if they're proportional, and if the scale factor is 8, I can multiply these lengths to get these lengths. If I know that this side length is 2, this side length is this side length is 1, this side length is 2, this side length is 3, I could find out what all of these side lengths are. Because I know that these triangles are similar. What am I saying? These triangles are similar. I can use my scale factor of 8 to find these side lengths. I would just multiply 1 times 8 is 8. So the corresponding side to 1 is 8. The corresponding side to 3 of this triangle is 3 times 8, which is 24. The corresponding side length to this is 2 times 8, which is 16. So that's pretty cool. So now we are going to get into the homework. And I know I went through that really fast, so I will be doing another video just kind of talking about scale factor more and just doing a ton of practice problems. Because there's a lot of vocabulary in this unit. It would be nice if we were at school, but because they're not, I'm going to have to kind of rush through it, but I'm going to post a lot of resources on Google Classroom to help you with the vocabulary. So I know this video is a little bit discombobulated. I will make another one and go through it a little bit slower. Okay, so additional practices at the top, and it's decide whether the two scale factors are the same or different. The same or different. And remember, we use scale factor when we're working with similar figures. So 1, if the scale factor is 3/4 and 0.75, well, I can kind of set up two figures to see if it makes sense. So I'm going to set up a rectangle with a length of 1 and a width of 1, which is a square, in case you didn't know that. So I know that these rectangles are similar. So I'm gonna multiply the scale factor by both the length and the width. 1 times 3/4 is 3/4. The length 1 times 3/4 is 3/4. So my new rectangle, well, really square, is 3/4 by 3/4. And let me do that with 0.75 this time. So 0.75 times 1 is 0.75. 0.75 times 1 is 0.75. Are these rectangles the same? Are the width and the length the same? Well, we know 3/4 is equal to 0.75 or 7/500. So yes. Question 1, the scale factors are the same. Now let's do 2. 3.5 and 35%. Well, I don't even need to set anything up for this problem. I just need to change a percent into a decimal. Now, how do I turn a percent into a decimal? I move the decimal places 2 places to the left. So my decimal is 0.35. And 3.5 and 0.35 are not the same. If you are having trouble changing percents into decimals, please comment below, because then I can do a little video reminding you how to change percents into decimals. And then let's look at question 4, because that's another one where you turn percents into decimals. So 6 and 600%. Are these the same scale factor? Well, all I need to see if they're the same is change a percent into a decimal. To change a percent into the decimal, there's always a decimal point after the last number in a percent. And all I need to do is move it 2 places to the left. And so 600% is the same as 6. 6 and 6 are the same, so the scale factors are the same. I'm going to post another video going over a couple more questions on this assignment, assignment 4. Comment below with questions. Thank you.